Hey there, momentarily we're going to simplify each side of the fraction here and simplify the fraction and state some excluded values. But before we simplify something that looks a little more complicated than that, what if we just reduced or simplified some fraction, maybe like 12/8? You've done this before, but I'm going to just write it a little differently. So this middle step is something interesting to think about. I know that 4 goes into 12 and 8. So instead of dividing by 4, I'm just going to show it this way. I'm going to show it this way. You'd never have to do this in the future, but, really, we see that 4 is a common factor of the top and the bottom. And so then these 4s are eliminated. And so when we divide by 4, we're left with 3/2. So this is a different way of visually showing that. And today, what's going to happen is we're going to simplify or factor polynomials instead of factoring. Really, I kind of factored 12 into 4 and 3, and I factored 8 into 4 times 2. We're going to factor polynomials like you've done in the past and do the prerequisites. If you're a little shaky on factoring, please take some time to review the videos that I linked to the lesson for 5.01. Because we're going to, from here, once you feel good with that, we really hit the ground running on this lesson, doing this reduction, reducing, eliminating the common factors that are in the numerator and the denominator. So, number 11 here. The first step is to try to factor the top and or the bottom. The bottom, we can factor a 2 and an n out of each or all of those terms. So on our left was 7n plus 8, 7n plus 8. And on the top, I can really break that into, 2n times 7, I suppose. 2m times 7, times 7, that's a dot for multiplication. And so this just gives me a visual that sure enough, I can factor a 2n out of the bottom, and a 2n also gets factored or can get divided out of the 14n. So we're then left with 7 over 7n plus 8. So this is our simplified solution. Then they also want us to state the excluded values. Whenever there's a variable or variables in the denominator, you need to be careful there because you can never divide by 0. And so, well, there was an n there that I'm pointing to in green. Come back. But there's also really an n. There's this initial n right here as well. And so you need to state the values that would make the bottom equal 0, and those values can't be part of our solution set. So 0 would make this factor equal 0. And if you solve 7n plus 8 equal to 0, you set it equal to 0 and solve for 0, you would get n equals negative 8/7. Subtract 8 and then divide by 7, and that's how they get that. So this, what they say here is that's the excluded value that you can't, it's not part of the domain, you can't put that in for x. That's what they're meaning with that notation. So they have the simplified answer first, and then the values that cannot be plugged into the domain. Number 14, on top I can't factor that at all, so I'm just left with x plus 6, but on the bottom I can factor out a 9. So then it would be 9 times x plus 6. Like up here in yellow, we have that common factor of the top and the bottom. Now our common factor is this x plus 6. It's a factor on top and it's a factor on the bottom. If you're like, well, Mr. P, doesn't factors usually have something multiplied with something else? Well, I suppose it's the same as 1 times x plus 6 on the top, right? There's one of them, so 1 times x plus 6. So then these get reduced. Ooh, yeah. So we have 1/9. That's our reduced answer, our simplified answer. And then if you look back at your original, if you plug negative 6 in there, you get negative 54 plus positive 54, which is 0. So negative 6 can't be part of the domain. All right, so here's how we can amplify this a little bit. Remember, we're We're trying to factor the top and the bottom if they're factorable. The top is not factorable, but the bottom is a trinomial. And I'm nice to you right now because there's a 1 right there. When 1 is right there, it's easy. You're just looking for numbers that multiply to 16 and add to 10. So we like to make this fancy diamond to kind of organize our thoughts. Numbers that multiply to 16 and add to 10, that's 8 and 2. So this bottom can really get written as x plus 8 times x plus 2. If you were to FOIL that together in your mind or on paper, you'd see that that equals the original trinomial. And then we still have this n plus 8 right there. So we have a common factor on the top and the bottom that we can cancel out. It's that n plus 8. Now just be careful. What is up there? What is left up there in the fraction bar? It's got to be a 1. There's one of these. This is getting, on top is getting multiplied by 1. So it's 1 over x plus 2. There we are. Let's try it again on number 22. So the top, I can't factor x plus 3, but I'm going to try to factor the trinomial on the bottom. It's a 1 right there. That's nice. So I'm looking for numbers that multiply to negative 27 and add to negative 6. Multiply to negative 27 and add to negative 6. Remember, if you make your factors of 27, it's 1 and 27, 3 and 9. But then it's a negative 27. So either the 1 needs to be negative or the 27 needs to be negative. Either the 3 needs to be negative or the 9 needs to be negative. And this is the magic combination right there. So that means I can take this into factored form. I can call it x plus 3 times x minus 9 over x plus 3. And so we have a common factor that we can cancel out. Plus 3 and plus 3. So we're left with 1 over x minus 9. Now for some of these sets, the directions will say they don't mention finding the excluded value, and I believe this is one of those sets. But looking at our factored form, it would be negative 3 to counter the positive 3. Negative 3, and it would be positive 9. But again, I don't believe this shows up. They don't ask for it on this set. On some sets, you'll need to, though. Alrighty, so that's factoring a equal to 1 and then reducing out or canceling out your common factors. It'll get a little bit more difficult. I'll cover this set in the next video.